This conference will now be
Sir.
recorded.
Okay. Okay. What is the last class? What is our last class?
So we've discussed independent events and dependent events from probability, and then you introduced the concept of permutation of multiplication rule.
Okay, so we are in the probability and the permutation combination problems. We seen it, right? Okay, fine. And this particular session, it's a very important for who are looking for data analyst position or data science position or business intelligence position. Okay, and here we are going to talking about very important things. So with help of that concepts from the Python, sorry, from the statistics, you can able to go for solve any kind of problem statement. Okay, so make sure that how to understand each and every point from today's concepts. If you're missed it, then it's your bad luck. Okay, and I'm just opening my document. So okay, guys, can you see my screen or not? Okay, yeah. So today's concept very important from the statistics, and so here we need to go for understanding the p-value. Okay, so p-value. So guys, in a machine learning algorithms or in data science or data analysis process, this is the p-value is the playing a crucial role. The reason is that most of the time, based upon the p-value only, okay, based upon the p-value only, we would like to go for concluding the model is good or bad. Okay, whatever the model you created with help of the machine learning algorithm, that we are going to conclude with help of this particular p-value only. Okay, so what exactly the p-value? P-value means it's a probability of event occur. What it is? Probability of an event occur. I hope you clear, right? For example, you have some distribution I have data something like this, and you plotted the data, and in this particular situation we are calculated the probability of one particular value. Okay, and here the value of the p, let me consider it's a 0.7, which means that basically the p value, it could be in between 0 to 1 only. Okay, the reason is that it's a probability, right? Probability range is in between 0 to 1. Let me consider I have a data and I just calculate the probability of that particular value, and here the probability is, for example, 0.7. What exactly the meaning of it? It means that, what is the mean of it? Mean for event 100 times, it means that event 100 times 70% of the event occurred. 70% of the event occurred. That means, for example, when you're doing on particular experiments, this particular event which is occur 70% time. Okay, out of the 100, 70% this particular event it could be occurred. That will be the meaning of the p value. Is it clear? Is it clear? So p value is nothing but it's just a probability, right? It's just a probability. Okay, so once if you understood this one, I would like to introduce that 3 more concepts. Just note this exam. Please note this one. I would like to go for next point. If you're done, please let me know so that I can start new 3 more concepts from the statistics.
It's done.
Okay. Now this is the p value, right? It's just a probability, right? Based upon this one, we are going to be considering that my my event, it could be occurred some percentage of times. Okay, but and this could be the dependent on one particular value. The value is, it's a significant value. What it is? Significance value. So significance value means which is not constant forever. It could be decided by the domain experts. So who are really have a good knowledge on that particular area or that particular technology or domain. Domain is nothing but it's a finance, maybe sales, or maybe insurance, Okay, different kind of domains we have it. Maybe the person is the domain expert, he would like to go for fix this particular value. Okay, so this value which is fixed, then my p value, it could be less than or equal to this particular significance value. Okay, so this is the p value which is always comparing with this is the whatever the p value previously we calculated. This is the p value which is always depending or which is always comparing with help of the significance value. This is the p value which is calculated by the statistical engineer or statistician, but this is the significance value which is fixed by the domain expert. Okay, even you have a good knowledge in the data science, but you don't have any knowledge on the domain, that particular area of the domain, so you could not able to consider what could be your significant value. The significance value, if you want to fix it, you need to interact with the domain expert and you need to have some kind of meetings with them. Okay, then the domain expert, he would like to go for fix some particular like significance value. Then after, as a statistician or data analyst or data scientist, you would like to go for calculated the p value. After that one, you would like to comparing this particular p value and your significance value. Is it clear my point? I hope you understood what exactly the significance value. Is it clear?
Yes, sir.
Okay, I hope you understood what exactly the p value and significance value, right? Now, and hypothesis testing, this is very, very important, guys. Hypothesis testing, so which means based upon the p value and significance values. Okay, and you would like to go for calculated this particular hypothesis, and here, and with help of this particular hypothesis, which is strongly, it is strongly defining that two things. One is the null hypo, and second one is alternate hypothesis. See, null hypo in the sense we can consider it could be H0, alternate hypo in the sense we can consider it could be H1. Okay, see what exactly this null hypo and what exactly this alternate hypo. Mansa, I think you have some knowledge on this particular area, right? Can you elaborate it?
Yeah, a little bit. Null hypothesis is whatever we want to prove, and alternate hypothesis is any new mean or new mean or anything that is we are trying to prove. I think it's pretty much that if something we already have is true, I think that's null hypothesis, and something we are trying to prove is alternate hypothesis.
Yeah, so basically this null hypo and alternate hypo, which is very, very important, and moreover, it's a little confused point. Okay, which one we want to consider as the null hypo and which one you want to consider as the alternate hypo. So most of the statisticians are facing this issue. Okay, so basically null hypo is talking about reality check. Okay, reality check. For example, let me consider I have the population. Okay, this is the mean. It could be, for example, this is capital mu, and from this particular population we are considering some sample data. So let me consider it could be x bar. See, reality check means what exactly the reality check. So our assumption is our population and our mean of sample, it could be the same. It is reality check or not? See, reality means you have some population and you have some sample from this particular population. So usually our assumption is in reality check is our population and the population mean and sample mean, it could be the same. This is one condition. Okay, let me consider one more example. And so you have a stock market. you are invested in stock market, okay, and there is some X company, and so this is as X company. Present, it could be the profit, and in past also it was in a profit only. What is our assumption? This is a till, right? This is the till information. My future information is it is also profit. Okay, this is my future information. So here, so my past and my present both are, it could be profits only, so that I could able to go for invest into this particular company. So see here, the reality check is, my reality check is my company, my future, in future my company it could be profit, in future my company it could be profit, that could be my reality check. So that I can able to consider it could be null hypo. Okay, I want to prove it, I want to prove it which is wrong, or I want to prove it which is correct. So that we will do with help of the null hypothesis testing and alternate hypothesis testing. Okay, is it clear my point? So null hypo is always a reality check. So you just need to remember only one thing. Don't need to remember alternate hypo, because of alternate hypo it's exactly opposite for the null hypo. Okay, so reality check, which means that null hypo is true, null hypo is true, or null hypo it could be the false, it could be false. That means our assumption it could be maybe correct, my assumption it could be wrong. That could be defined by the reality check. Reality check is always talking about null hypo. That you just need to remember only these things. Okay, so based upon this information, based upon the reality check and null hypo, null hypo true or false, we have the four type of outcomes. There are four type of outcomes are there. My first outcome is, null hypo, null hypo rejected. Let me consider you just calculated some statistical operations, then from that one your null hypo is rejected. Okay, when reality check, but actually in reality check also, in reality null hypo is also false. In reality null hypo is false, which means that whatever you calculated that it could be correct. Okay, in reality check also the null hypo is false, and actually you are rejected null hypo, you are rejected the null hypo. In reality check also you are proving that the null hypo is false, and in originally from the statistician he was proving that it is rejected. So both are, it's talking about negative only, right? So that it could be correct result. Okay, this is the one outcome. And the second outcome is, you are accepting the null hypo. Sometimes you know what, maybe you did some wrong calculations. Okay, you did some wrong calculations and you are proving that the null hypo you are going to be you are rejecting the null hypo, you are rejected. Okay, you are proving that your null hypo is rejected, but actually in reality, in reality check, what exactly the null hypo? Null hypo is true. Is it error or is it correct? Tell me. Let just a minute, guys. See guys, in reality check, it was proving that it's a true. Our null hypothesis is true. But actually the statistician, he was proving that it's a rejected. So is it error or not? It's an error. Okay. In the meanwhile, you have the null hypo. The null hypo, you are accepted. uh, The statistician is accepting the null hypo, but in reality check, what it is? In reality check, the null hypo is false. So this could be also an error or not? 100% it could be an error. Okay. And we have one more point is there. Maybe both are true. Maybe both are true. In reality check and the statistical operations, both are accepting. That means the null hypo is accepted. In reality check also is true. And reality check also, it could be a true. So this could be, if it is the true, which means that it's a correct, right? Yes, it's a correct. So you can consider it's a S. So here we have second option and third option. This both are errors. Okay. These errors, usually we are calling it say type 1 error. This one error name is, it's a type 1 error. And here this could be type 2 error. So just note this particular example, guys. This type 1 error and type 2 error, usually we will see in a confusion matrix. Okay, we will see in a confusion matrix. So let me consider this particular hypothesis. Based upon the null alternate hypothesis, we have the 4 outcomes are there, and based upon the reality check and the statistician what he proved it, based upon these two particular things, there are 4 options are there: true true, false false, true false, false true. Correct? Just note these 4 points. I'm just waiting for here. If it is done, please let me know. Okay, I hope you written this particular 4 points, right? Now, in machine learning, by the time of implementation of some kind of classification techniques, so we would like to see one particular matrix. The name of the matrix is, it's a confusion matrix. What it is? It's a confusion matrix. So when it is the confusion matrix, see here we need to remember the two things, actual and predicted. Okay, actual versus predicted. So this is my true. So this is, for example, positive, and this could be the negative. Okay, and this is true and this is false. Okay, so this is actual data. Let me come to, this is actual and this could be the predicted. These values are predicted. Okay, so here predicted is true and actual is also true. So true versus true, so that means this is correct only, and actually it's a true but you predict it as the false, so that it's a true negative. Actually it's a false but you predict it as the true, or that means positive, so false positive. And this one is false and this one is false, that means not correct. And so actually it's a false but you correct it as the negative, right? So that's a true negative. True false negative, sorry, false negative. Okay, so here this is the confusion matrix. So this one and this one could be correct results, and this one is the wrong results. So this error and this error we are calling it same type 1 error or type 2 errors. Okay, false positive rate. So this false positive rate, so PPR. Okay, that means we are talking about this one, right? FER, false positive rate. So this kind of error we are calling it say type 1 error. Okay, so here, and true n, TN, right? TN in the sense true negative rate. True negative rate. So this kind of error we are calling it say type 2 error. So previously what we seen in the hypothesis, the same thing we are replicated with help of the confusion matrix. From the confusion matrix we have the predicted versus actual. Actual is the true or false, and you predicted as the positive or negative. Actual is true and predicted is the positive, then it could be the correct result. Actual is false but you predicted as the negative, that is also correct. So in these two cases it could be correct results, but actually it's a true but you predicted as the negative, that means it's a type 2 error. Actually it's a false but you predicted as the positive, that means it's a type 1 error. Okay, just note this example, guys. Done? Hello?
Yeah, done.
Yeah, you know, sometimes we will see one tail test and two tail test, right? What is one tail test and what is two tail test? So most of the statistical situations we are going to applying either one tail test, either two tail test. What is one tail test and what is two tail test? So at what situations we can apply this, any one of it? Actually, this is the test. It can proving that your alternate hypo is true or false, or null hypo is accepted or rejected. That we can prove with help of this particular one tail test and two tail test only. But actually, which one you want to consider, it's a totally depends upon the problem statement. Okay. So whether you want to go with, depends upon the problem statement in the sense your business case study. Based upon the problem statement, either we can apply either one tail test or two tail test. Did you clear my point? Based upon the problem statement, either we can go for apply the either one tail test, either two tail test. See, let me consider this is my, okay, this is my distribution, and if it is the two tail test, we have to consider the both sides. Okay, for example, let me consider your significant value. It could be 0.05. This is domain expert was giving that alpha value. This is my significant value. Then this is a significant value. When it is the two tail test, then you have to make it alpha by 2. So that means 0.025 here and 0.0525 here. So you have to take it to the significant value both sides. Then that could be two tail test. Okay. For example, if it is the one tail test, so the distribution can be the same only, but let me consider my alpha value is 0.05. Okay, and it is the one tail test. Either you can go with, either you can take it alpha value either this side, okay, 95% of the data this side, and 5% of the data this side. Okay, this is my 0.05, and here this is the 95% of the data. So here 25%, sorry, 2.5% of the data here and 2.5% of the data here, we are segregating in both sides. Okay, maybe this alpha value, maybe you can consider left side. When you considering the alpha value is the left side, okay, so here my alpha value is the 0.05. That means 5% here, and rest of the 95% can be this side actually. Okay, so these two are the one tail test. This one and this one is the one tail test because of you're taking only one side. You're not considering the both sides, either less or greater. This situations we can go with this one. So in between, if you want to calculate some range of distribution, then we can go with the two tail test actually. So based upon the problem statements, the one tail test and two tail test you could be considered. Okay, please note this one tail test and two tail test. Which one is the one tail test and which one is the two tail test, guys?
The one with both sides is a two-tail test, and right and left, I mean, either way is one-tail test.
Yes, this is two tail test, and this one is one tail test. Either this one is also, it's a one tail test because of you're taking only one side distribution. You're not considering the both sides. When you're considering the only one side, then it could be one tail test. When you're considering the distribution in two sides, okay, then that could be the two tail test. Okay, just note this example. It's not example, you just remember these points.
So I have a question here. In real world scenarios, the significance value can be anything, right? Not just 0.05.
No, the significant value can be anything, but it can be fixed by the domain expert.
Okay.
Here I can
so
consider,
we are just comparing. Okay, yeah. I'm sorry. We are just comparing the p-value against the value that's given by the domain expert, right?
Absolutely correct. Absolutely correct. The p-value, it could be calculated, or it could be determined by the statistician. Okay, that means we are okay, but you are not having the domain knowledge. So then what we will do? This is the value, I got it, but can you please tell me what is our significant value? And that meetings we can consider with the domain experts. Okay. Then the domain expert is giving the alpha value. Then based upon that significance value and what we calculated p-value, you are going to be proving that our null hypo is true or false. Okay.
So all those confidence intervals like 99%, 90, 95% and all, that will come after we get the significant value from the domain
Absolutely.
expert.
Yes, domain experts who are having. So that means, so even you have only knowledge in statistical knowledge, you can't be determined. You can't be considered. You are a data scientist. Okay, you are a data scientist. You are a data analyst. That situation. So when you are become
Okay.
like data scientist, when you have really knowledge in a domain, okay, so then you are become like a data scientist actually. So this confidence interval values, lower value and upper value can be calculated based upon the significance values only. Okay.
Okay.
So without knowledge on the domain, then how you can calculate it, the what range you would be considered, right? So that's the reason. So one person can't be implemented the data science applications. Okay.
Yeah.
So domain people
Thank you.
and statisticians people required, machine learning engineers are required, and programmers also required. Okay.
Yeah.
Okay.
Thank you.
Yeah, no problem. This is about the one-tailed test and two-tailed test and hypothesis and confusion matrix, significance values, and p-value. Okay, and you can go with any kind of interview. They might ask the question, what is the difference between the p-value and significant value? So the right answer is p-value is nothing but the probability of one particular event is occurred, but significance value, it can be fixed by the domain expert. So based upon the problem statement, based upon the domain, the significance value can be determined by the domain experts. Okay, this is actually right answer. So people can be confused about what is p-value, what is significance value. So both are different, but both are talking about same thing. Okay, I hope you clear. And by tomorrow class we will talking about confidential intervals, CA values, how we can able to calculate the CA confidence intervals, and those particular things by tomorrow's class we will be considered. In the meanwhile, one sample jet test and two sample jet test, t-test, and ANOVA test, chi-square test, and central limit theorem, and this all statistical test we will be considered by tomorrow's class. Okay.
Sorry, one question I had. What are the most common technologies that are used for this kind of specific statistics in the real world? Like I have used Excel before, but what are the most common tools that are used?
So Excel is the old one, but still they are using. Okay. The reason is that in Excel, lot of data analysis related libraries, predefined libraries are there. Okay.
Okay.
And second one is SPSS and SAS
Okay.
and SPSS, SAS, and R language, R and Python. These are the most popular tools we are using for this kind of things.
Okay. Okay. Thank you.
Yeah. Bye. Take care. Take care, guys. Bye. See you.